Example 6, identifying end behavior and degree of a polynomial function. Describe the end behavior and determine a possible degree of the polynomial function in figure 7. So if we take a look at the graph and look at the end behavior of both of them, we can see that it's falling on the left and then rising on the right. So here is the end behavior. Okay, so and then recall that when we look at this function, okay, we can see that as the x values get larger, meaning that as it's approaching positive infinity, so as the input values of x get very large, then we see that the output is going towards positive infinity, meaning that the output values of f of x increase without bound. And then if we look at the left side of the graph, as x is approaching negative infinity, so as the input values of x get very small, going towards negative infinity, then the value of the function is also going towards negative infinity, meaning that the output values of f of x decrease without bound. So when we write that in terms of x, we would say that as x approaches negative infinity, then f of x approaches negative infinity. And as x is approaching positive infinity, then we're saying that the output f of x approaches negative infinity. So in words, we could say that as the x values approach infinity, the function values approach infinity, and as x values approach negative infinity, the function values approach negative infinity. Well, we can tell this graph has a shape of an odd degree power function that has not been reflected. So the degree of the polynomial creating this graph must be odd, and the leading coefficient must be negative. Well, let's go back to our definitions. Okay, so there's 4 scenarios of identifying end behavior polynomial functions. So it's not the first one because it's rising on the left and rising on the right. And that's when you have a leading term is positive and an even power. And it's not the second scenario where it's falling on the left and falling on the right. If we go to the third scenario, it's falling on the left and rising on the right. So if we go back to this question, it's falling on the left and rising on the right. Well, what do we know about that? Well, when that happens, okay, we're going to have a positive leading coefficient with an odd power. And that's how we're getting this answer here. We can tell that this graph has the shape of an odd degree power function that has not been reflected because it's falling on the left and rising on the right. So the degree of the polynomial creating this graph must be odd. And the leading coefficient must be positive.